Good morning from Santa Cruz, California. Today we're working on word problems, and there are a billion of them on the SAT. So I'm going to split this into a couple of, at least two, possibly three videos, so they're not too long. Okay, so the first one we're going to work on is Test 1, Section 3, number 11. Now, word problems can look like anything, and they can cover any math subject. And that's why there's going to be a lot of these that we're reviewing. So if we look at 11, we see two equations, and you don't have to know anything about the equations. I'm just going to leave off the zero here. I don't know why. I just really don't like to have the zeros on. I find that it is a place where it's possible to mess up. Anyway, it says in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1 during last summer. Now, remember, I keep repeating myself, but I really want you to get this into your head. It's not even really necessary to read that first sentence. Whenever there's a picture, in this case, a series of equations, a chart, a graph, a table, there's always the first sentence that describes that. And most often you do not even need to read it. You can just go right to the question, which says, what was the price per pound of beef when it was equal to the price per pound of chicken? Now, I love this question because literally embedded in the question is the method. It tells you what to do. It says, what is the price of pound per beef? Well, that's the B, right? That's 2.35 plus 0.25x. When it was equal to, put an equal sign, the price per pound of chicken. That's there, and then you write this down, okay? This is literally all you have to do. Okay. So let's just begin by solving for x. We're going to subtract out the 0.25x, 0.25x, and we get 0.15x, and then we're going to subtract out the 1.75, 1.75, and we're going to get 0.60. So we get 0.60 equals 0.15x. We're going to divide that out by the 0.15, and we're going to get x equals 4. Now, the hardest part of this problem, I think, is doing this right here. Most of my students have not done division with variables in a million years. And this is section 3. You can't use your calculator. So I just want to go over that quickly. All right, we're going to do old school long division. Okay. So remember, you can't do division when you have a decimal point. So you have to move that decimal point. I'll use a different color. You go 1, 2. So now the decimal point's after the 15. It's just a regular 15 instead of a 0.15. So you're moving that decimal 2 places, so you have to move it 2 places on the inside, and your decimal point goes here. And now you just have 15 into 60, which is 4. Okay, so really the big takeaway, I think, in this word problem is this. So know your long division with decimals. All right, now if you look, we have x equals 4, but 4 isn't in our answer choices. And that's because we haven't solved the problem yet, because x is the number of weeks, right? So now we have to take this 4 and plug it back into one of these equations. And it doesn't matter which one, since the equations are equal. So let's just put it up here, just for ease. Now, we know that 0.25 is, you can think of it like a quarter, 25 cents. 4 quarters is $1. So this is going to be equal to 2.35 plus $1, which is 3.35. And our answer is D. This is one of my favorite problems. I really enjoy that. Okay, moving on. We're going to go to section 2 now. And, sorry, section 4. Why did I say section 2? All right, so section 4, let's flip over to number 20. So I'm going to clear this out and Test 1, Section 4, number 20. And this is another question that I love. And we're going to learn a different strategy here. The strategy is called a plug-in strategy. But let's first read. Maybe I'll write in plug-in. Okay, so it says Alma bought a laptop computer at a store that gave a 20% discount off its original price. And we stop and we write something down. Here, I'm going to write down the original price, which we don't know, and a 20% discount. Okay, now it says the total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. So we add to that 8% tax, and then we'll have a total. And then the question says, which of the following represents the original price of the computer in terms of P? So let me tell you why I love this problem. We get to plug in, all right? And here's how we know we can plug in. If we look at every single answer choice, they all have variables in them. So you use this plug-in strategy when there are variables in the answers. All right, whenever you see variables in the answer choices, you can use this as an option, this plug-in strategy, and I highly recommend it. You don't have to. If you see another way in to the problem, then great, do it however you see to do it. But if you think that the problem is hard and you can't really get into it, you can't really see for yourself the way to solve it, use this plug-in strategy that I'm about to show you. So we don't have an original price, so we are creating one. In other words, we're plugging in an original price. Now, because we're dealing with percentages, the easiest price is 100, because that makes our math super simple. Now, a 20% discount is the same thing as saying 20% of 100, which is also, as a little reminder, I mean, this is easy. You could probably do this in your head, but if you can't, it's just a reminder of how to do percent. 20% is 0.2, of is always multiplication, and 100 is 100. So 20%, 20% is 20. And let's just make this. Okay, so we have $20 off. So minus $20 is going to be $80. So $80 is our discounted price. Now we have to add the 8% tax, 8% of 80. And they do say that the 8% tax is on the discounted price. So 8% is 0.08 times 80, and that's going to give us $6.40. So we're going to tack on $6.40 to that, and we have a total price of $86.40. All right, so this is, and that's our P, right? That is by definition. In the problem, it says that the total amount she paid to the cashier was P dollars. So this is our P. Now, the question asks, which of the following represents the original price of the computer? Now, we created the original price. We just made that up. That was our plug-in, right? Right up here. So $100 is the original. And when we solve the problem, we circle it. All right, now this is important because it's easy to get these numbers confused. And that's why your page should look exactly like this screen looks. Everything is organized, everything is labeled. We know what P is. It's not just some 8640 floating out there in the wind. All right, now when we look at the answer choices, let's just take A, for example. It says 0.88P. Now what we're going to do is we're going to plug in the P. We're going to plug in this number here for P and try to get 100. 100 is our target. That's why we circled it. All right, so if we take our calculators, and luckily this is the calculator section, and we multiply 0.88, I'm going to do this right now on my calculator. You can do it on yours as well, times the 8640. We're not getting 100, right? We're getting 7603. That is not the answer. We need to be getting the 100. And you can just go right down, right now, you can do it. right down through B, C, and D until you get 100. You will find that D is your answer. Now, if you look at D, you'll see that chances are very slim that you would have thought that D was right just by looking at it. In other words, if you didn't do the plug-in strategy, and if you're just going to try to use logic to solve this problem, you'd probably get it wrong because it just doesn't seem like it makes that much sense. But when you do the math, it works. So plug-in strategy is a very, very strong strategy when you have a more difficult problem and there are variables in the answers. Okay, so let's go on. I'm going to clear this off. And let's stay in the same section. So it's section 4, number 25. All right, and we have an equation here. We've got negative 4.9t squared plus 25t. All right, and it says the equation above expresses the approximate height h in meters of a ball t seconds after it's launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately, now remember, whenever you see the word approximately, what do? You circle it. Because we know we're going to be able to round, and we're not going to freak out if we don't get the exact answers in the answer choices. After approximately how many seconds will the ball hit the ground? Okay, so they said t was seconds. And they are asking us to solve for seconds. So we are solving for t. The problem here is that, well, we already have another variable. So we need, in order to easily solve for t, we need to have h be a number. And then we can do algebra to solve for it. But that is our initial issue, is what is this h? Now, if we go back to the question, it says, after how many seconds will the ball hit the ground? So when the ball hits the ground, there is no height. It's at 0. So this is good because now we can just turn the problem around so it looks a little bit more normal, more like a quadratic where we have the second power first. So I'm just turning it around. Okay, now we have something we can work with. So what should we do? I see that we can pull out a t in each, right? So if we do that, we pull out a t, we end up with negative 4.9t plus 25 equals 0. And then we set each of these equal to 0, this one as well as that. So the t is equal to 0, that's fine. And then we have negative 4.9t plus 25 equals 0. And great, we can absolutely do this, right? Easily solvable for t now. We're just going to get that 25 over to one side, and we've got the negative 4.9t, and we'll just divide out that, 4.9. We'll get rid of that, negative 4.9. And luckily, we can use our calculator. When we do that, we get a 5.1. Well, we know it's approximate. So our answer is actually going to be 5, which is D. Okay? All right. So take note. And I'm going to move on to number 27. Now, 27 has a chart with a lot of numbers, or a table, and it's got a lot of hoo-ha at the top. Now, like I said before, normally I don't read anything, but I do see some numbers up there. If it's all just words, then I'm not too concerned. But I see this 10 by 10 thing, so I think I want to read it a little bit. And the top says, a square field measures 10 meters by 10 meters. So I'm just going to draw this out because when they tell me something, just like in any geometry, right? If they don't give me a picture, I want to draw it. So we've got a 10 by 10. And it says 10 students each mark off a randomly selected region of the field, and each region is square and has a side length of 1. So what that's going to look like is that. We have like a little 1 and a 1. Okay? Now, I'll continue. It says no two regions overlap, and the students count the earthworms contained in the soil to a depth of 5 centimeters, and the results are shown below. Okay, so I flip down to the question below the chart, and it says, which of the following is a reasonable approximation right? So we have that word approximate or approximation. We're going to circle that because we know we're going to round. Approximate number of earthworms to a depth of 5 centimeters, that stays the same, beneath the ground surface in the entire field. So what's happening is those regions are really this, right? These little small 1-by-1 areas. And that's what you have in the table. Okay. Now, I also want you to look at the answer choices. If you see they're all 150 with varying numbers of zeros at the end. Okay, so it's either 150, 1500, 15,000, or 150,000. So we know our approximation. We can say with some certainty that the average number of worms in the small section, right, in the little pink section, the 1-by-1 section, is going to be 150, right? Because if we look at all of the answers or the numbers in that table, we can say, all right, they're all fairly close to 150. If we average them out, we probably get that. But we don't have to do that work because they've essentially done it for us in the answer choices. So that's great. Now, if we know that in this little section there's 150, well, they're asking for the total number of earthworms in the entire field. And in fact, what would be good for you to do is circle in the entire field, right? So that lets you know the answer is not going to be 150 because that's only in the small section. We have a total area, excuse me, length times width, or side squared, since it's a square, of 10 times 10, which is 100. So if we multiply this 150 by 100, then we're going to get the total number of worms in the whole field. So that's 150. And then when you times it by 100, you add on 2 zeros. So that's going to get us 15,000, which is answer C. All righty? I hope you get that. All right, let's go to the grid-in section. All right. And now I've got some room here, so I think I'm just going to draw a line. All right, and then let's look at number 32. All right, it says the posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. So already I stop, 6,000 pounds, and that's the limit. Okay, a delivery truck that's carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. So there are X boxes, and they're 14 pounds each. Okay, you see how I'm doing this? Just writing it down so I am looking at my own handwriting rather than having to go back and reread all their words. I'm just kind of shortcutting it here. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? Ooh, that's a lot of words. Okay, so we have 4,500 pounds, and that is, what is that? That's the truck and the driver. Truck plus driver. That doesn't include the boxes. And they're saying, what is the maximum possible value of X? So the number of boxes. All right, so we want the maximum number of boxes. Right, now you never have to read the problem again. We have it all here. Okay, now let's look. We've got a limit of 6,000. Now we're going to start to do some math. We already know that the truck and the driver, should be singular, is 4,500 pounds. So we've already taken up 4,500 pounds. So we can get rid of that. And we have 1,500 pounds left to deal with. Now we know that the boxes are 14 pounds each, and we're trying to find the number of boxes. So if we divide 1,500 pounds by 14 pounds, right? This is, yeah, okay. And we will get, let's see, do that quickly on your calculator. We're going to get 107, I think. Let me just do that, make sure. Let's see if that's exact. No, it's 107.14. All right. Now, of course, this did say, what is the maximum possible value of boxes? Well, you can't have 0.14 boxes. That doesn't make sense. So the maximum number of boxes is going to be 107. All righty. Great. And let's do one more on this test. And I think that'll do it for us. So I'm going to clear this out. And let's go to number 34. And we read, a local television station sells time slots for programs in 30-minute intervals. Guess what we're going to write? 30-minute intervals. All right. If the station operates 24 hours per day, every day of the week, 24 hours per day, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So we want Tuesday and Wednesday. It's going 24 hours a day. So Tuesday is going to be 24 hours and Wednesday is going to be 24 hours. So we have a total of 48 hours. However, this 30-minute intervals means that in 60 minutes or 1 hour, we have 2 time slots. So this is the key right here, right? This is the thing. If you don't get that, you're not going to get the problem right. So we simply, instead of having 1 per hour, which would make it 48 time slots, we have 2 per hour. So we multiply it by 2 and we get 96 as our answer. All right, that is all I've got for test 1. I think that's enough. I'm going to see you on the next video for test number 2. Take care. Bye-bye.